Hello, friends. This is our AI A to Z series, and I'm Dr. Sonali Tamankar. Today, we have AI for the grader. V is for verifiability. By grader, I don't just mean teaching assistants grading college homework, I mean all of us. When we are standing in the grocery aisle deciding which popcorn to buy, we are grading different brands. This one I've had before. That one says movie theater. That one says all natural. Even the colors, graphics, and fonts on the packaging influence which brand lands in our shopping cart. If you were a popcorn company, all your effort mostly comes down to this moment of truth. The grade the consumer assigns to your product as judged by what lands in their shopping cart. If a popcorn company makes the claim that their product is the most popular one out there, this is a verifiable claim. You can just compare sales from last year. Not all claims are verifiable. Imagine if I told you that a small porcelain teapot orbits in the sun between Earth and Mars. You may think me crazy for making such a claim, and you may feel this can't be true. But how would you prove it? An object that small in that orbit would be effectively impossible to detect, even with today's technology. This was exactly the point that famous philosopher and logician Bertrand Russell sought to make. In fact, this thought experiment is now known as Russell's teapot. It's the classic dodge of yesteryear. The check is in the mail. Easy to state, impossible to verify. And that's the point. Let's bring this back to AI and look at a few healthcare examples through the lens of what is easy to generate and what is easy to verify. Let's look at the first quadrant. Transcribing a doctor's notes is an example of something that is both easy to generate and easy to verify. That doesn't mean it's perfect, but we have good AI systems today that create written text from recorded audio, and it's easy for a human to verify that transcript against the recording. Because verification is easy, errors can be flagged quickly, and that feedback can help AI systems improve further. Now let's look at another example. If you describe a patient's symptoms to an LLM today, it will generate a possible diagnosis for you, maybe even a list of differential diagnoses. This clearly falls in the easy to generate category now. But how do you verify it? At the very least, you need tests and a trained clinician, even for relatively simple cases. Now, if an AI system claims to detect cancer years before it is visible on any scan, verification becomes even harder. You may not know whether it was correct for a very long time. Now, consider a different problem, nurse scheduling. You specify all the constraints, how many nurses are needed for each shift, union rules, and individual preferences, and ask an AI system to produce a schedule. Such schedules can be notoriously hard to generate when all preferences are taken into account. On the other hand, verification can be relatively easy. Nurse Jude said she can't work on Saturdays, and here she is scheduled to work on a Saturday. An example in the final quadrant is drug discovery. This is hard to generate. Even proposing a chemically plausible molecule is non-trivial. It's also hard to verify. We need controlled clinical trials to establish safety and efficacy. This brings us to software 1.0 and software 2.0 as characterized by AI researcher Andrej Karpathy. Software 1.0 automates what you can specify. The idea is software 2.0 will be able to automate what we can verify. When we first started programming computers, we had to specify the exact rules explicitly. Now we use machine learning systems that learn patterns from data. Karpathy also famously said that English is the new programming language, what he sometimes calls software 3.0. He coined the term vibe coding, where we start with an idea, ask the computer to write code, and iteratively refine it through prompts. Verifiability here can be simpler. The application either behaves the way you want or it doesn't. If you're using LLMs to write complex code, verification becomes vitally important and harder. The developer burden is now shifting from writing code to verifying what the model generates. Is it correct, secure, and efficient? If we extrapolate into the future, it can be argued that tasks which are easy to verify are the ones that are most likely to be automated first. To me, this connects directly back to our earlier episodes on training data and supervised learning. With powerful learning algorithms, the ability to generate high quality labels and provide clear feedback enables highly effective AI systems. AI researcher Jason Wei summarized this idea as the verifier's rule. The ease of training AI to solve a task is proportional to how verifiable the task is. All tasks that are possible to solve and easy to verify will be solved by AI. Okay, that's the predicted future state. What about the current state? Technology has advanced rapidly but unevenly. This has been described as the jagged edge of AI. I've linked a Harvard working paper below that studied 758 consultants at Boston Consulting Group to understand how AI affected their work. The authors describe a jagged technological frontier. Some tasks are easily done by AI, while other tasks, which may appear similarly difficult, remain outside the current AI capabilities. For tasks within the AI frontier, consultants using AI were significantly more productive, no surprise there. But for a task outside the frontier, consultants using AI were 19 percentage points less likely to produce correct solutions than those who did not use AI. In these cases, AI actually made performance worse. The paper also describes different modes of AI and human collaboration. Centaurs, who allocate tasks to humans or AI based on strengths, or cyborgs, who integrate human and AI capabilities more tightly. Now, this is my personal observation, but I find it interesting that the task identified to be outside the frontier in this study is actually more verifiable than the task inside the frontier. I think today's AI is particularly strong at creative and subjective tasks. For complex, verifiable tasks, AI can be extraordinarily effective when it is purpose built. Protein folding is a great example, but there remain many complex, verifiable tasks that sit outside the current frontier. I hope you enjoyed this walk through the state of AI, current and future. So we talked about the verifier's rule, the ease of training AI to solve a task is proportional to how verifiable the task is. I hope the centaur versus cyborg framing helps you reflect on how you personally use AI. And it's important to remember the jagged edge of AI. Using AI for tasks outside the frontier can reduce accuracy rather than improve it. The frontier is constantly moving. Tasks that were outside of it yesterday may be inside today. But for the foreseeable future, there will be tasks outside the frontier. And for these tasks, it's important to trust our own judgment over AIs. Please share your thoughts and comments. Tomorrow we have W is for workflows, where we'll look at another example where using AI actually caused more burnout. See you then. Bye for today.